So we are working on more on the first derivative test right now. The first derivative test is when we determine whether or not a function has a maximum or a minimum. So start with something we know. We have a quadratic function here, right here, which is a parabola. This opens upwards, so we know f will have a minimum. There will be a minimum right here. Examine the graph of this parabola and describe the behavior of f prime around the minimum. So at the minimum, you can see that f prime is equal to 0. To the left of f prime, to the left of this, f prime is less than 0 or negative. F prime is negative because the slope is negative, the function's decreasing. And to the right here, f prime is positive. So whenever you have a minimum here, like this, f prime's going from negative to 0 to positive. You see f prime's negative, then it goes to 0, then it goes to positive. That's a min. So let's say what a max, so that's for, in this example right here, for this graph here. Let's say we wanted to get a max. The max can look like this. So in this case, f prime is going from positive, you see it's positive, to a critical point, so the derivative could be 0 or dne, like in this case, to negative. So in other words, this max here is when f prime shifts from positive to negative, and there's a min when f prime shifts from negative to positive. This you'll have to remember. Min, f prime goes from negative to positive. Max, f prime goes from positive to negative.
Positive. Second one.
Let's write that down right here. There is a minimum value at x is equal to c because f prime changes sign from negative to positive. There's a maximum value at x is equal to d because f prime changes sign from positive to negative, just like that. So use the first derivative test to find the x values of any relative extrema of f of x equals x squared minus 4 to the 2/3 power. Again, this is where we have to find, well, we have to first find the critical points. Where is f prime equal to 0 or dne, f prime dne. So let's find the derivative here. F prime of x is equal to 2/3 times x squared minus 4 to the negative 1/3 power multiplied by 2x. And that simplifies to 2 times 2x is 4x on the top. And then the bottom is just, one sec. And the bottom is just equal to 3 times the cubic root of x squared minus 4. So the critical points are when, let's see when f prime is equal to 0. F prime is 0 when x is equal to 0 because that's just the top of the function equal to 0. Um, Now let's find when f prime does not exist, when the bottom of the fraction is equal to 0. We just have to find this cubic root, make this inside 0, and that happens when x is equal to negative 2 and 2. So now we're going to have to draw a pretty large table. X, let me use the line here. We have an x there. F prime of x. Just skipping ahead, get this all down. I got the critical points written down. When x is 0, the derivative is 0, and here it's d and e. And now what you want to do, just write out all the intervals here. Negative, always start at negative infinity to negative 2, and just connecting everything together. Negative 2 to 0, 0 to 2, 2 to infinity. Similar to the previous lessons, this is where we just plug in a value inside the interval and test whether the derivative is positive or negative. So right here, let's take negative 5. 4 times negative 5 is negative 20. That's a negative on top. If we did plug in negative 25, well, that'd be a cubic root of, well, negative 5 squared is 25 minus 4 is 21. And the cubic root of 21 is a positive number. So the bottom of the fraction here is positive and the top is negative. So a negative divided by a positive is negative. Negative 2 to 0. Let's try plugging in 1. 4 times 1, sorry, negative 1. 4 times negative 1 is negative. And then the inside this cubic root, negative 1 squared is 1, minus 4 is negative 3. The cubic root of negative 3 is a negative number. You're going to get a negative divided by a negative. So this is a positive. Between 0 to 2, let's pick 1. 4 times 1, that's positive on top. And then 1 minus 4, that's negative 3. Cubic root's a negative on the bottom, so we're going to get a negative on the bottom. 2 to infinity, let's pick 5. We get positive on top, positive on the bottom. If I went pretty quick here, so if you have questions with how I got something here, please, you need to ask the teacher or ask one of your classmates who have already completed this lesson and demonstrated mastery. So, a minimum is when f prime changes sign from negative to positive. You see right here at negative 2, f prime goes from negative to positive, and then also at 2, you're going from negative to positive. So min at x is equal to negative 2 and x is equal to 2 because f prime changes from negative to positive. Vice versa, there's a max at x is equal to 0 because f prime changes from positive to negative. You're going to eventually run into cases where there might not be a sign change, like it'll go from positive to positive or negative to negative. In that case, it's not a max and it's not a min, it's just nothing. Next example here. We talked about this before, but if h of c does not exist, then x is equal to c cannot be a critical point. We're going to see an example right here with this. Find the relative max or min of the function h of x equals x squared over 4 minus x. So let's find the derivative here. H prime of x is equal to low d high minus high d low over low d high minus high d low over low. That gets us a 8x minus 2x squared plus x squared over 4 minus x squared equals, oops, ugly equal sign, equals, you can factor out, well, it becomes 8x minus x squared over 4 minus x squared. You can factor out the x, 8 times parentheses 8 minus x over 4 minus x squared. So if you look at all these critical points here, well, we have to first find, so this is the derivative, right? When is the derivative equal to 0 or does not exist? So it equals to 0 when the top of the fraction is equal to 0. That's when x is 0 or x is equal to 8. Now let's look at when the derivative does not exist. That's when the bottom of the fraction is equal to 0. That's when x is equal to 4. However, this here is not a critical point because if you plug the 4 into the original equation, it's a 4 squared 16 over 0. That does not exist. If h of c does not exist, then x equals c cannot be a critical point. So this right here is not a critical point. And I'm just going to show you in a table. So negative infinity to 0. Pause if you need to write this down. 0 to 4, 4 to 8, and then 8 to infinity. So if you pick a number between negative infinity and 0, like a negative 2, you'll get a negative on the top and the positive on the bottom. So the derivative is negative. If you pick a number between 0 and 4, like a positive 2, it's a positive positive over a positive, so you get positive. If you pick a number between 4 and 8, you'll get a positive over a positive. If you pick a number 8 to infinity, like a 9, it'll be a negative over a positive, and you get a negative. So you see here, even though we include the 4 here in the table, you can see that at x is equal to 4, the derivative is going from a positive to a positive. So at 4, it's not a max or a min. So we can write out our answers right here. Find the relative max or min. Min at x is equal to 0 because f prime, running out of room, goes from negative to positive. And then there's a max at x is equal to 8 because f prime goes from positive to negative. So one thing to note here, sometimes problems will ask you what is the maximum value, and some will ask you where is it. If they ask you where is it, just say like where is it? Like what at x is equal to what? If they ask you to find like what is the maximum value, you have to plug in where it is into the original function. So you have to plug in wherever it is into the function and obtain that value. You can go ahead and start the practice. Any questions, please ask your teacher.